Some things. First detail, midterms. We're going to use our midterms to review. Go ahead and start reviewing some for the AP exam. What we're going to do with that is I will pass midterms back after I've made scans of them, and we're going to meet during advisory when we can all get together and talk about different questions. Now, what I will say is this. I'm not going to make everyone come every single day, because if you got a certain set of questions right, then I'm not going to make you come for those. But I think for the most part, most of us are going to need to come for the study design stuff, maybe some of the probability, things like that. So I'll let you know what days those are coming up. Make sure that we schedule so that those who need to come can come. Before I get to the new project, I was wavering on what to do about the study design, because as Deacon said, at this point, Pete, what was the wording you used? People are just going to turn it in because they don't care?
Oh yeah, people will take the L.
People are going to take the L. It's not acceptable though, because we have got to understand, guys, we got to understand study design. I don't like seeing in an AP class seeing seeing D's. We need to get those grades up, which means I need better understanding of concepts. One thing I will say is, some of the retests I still have to grade, so that will hopefully bring some of us up. But either today or tomorrow, we are going to sit down during advisory, and we are going to talk about the study design. Go for it.
Juniors are
Which junior? Are y'all?
I'm the first group, and next whoever did call us.
Doing the whole week?
Yeah.
You're doing the whole week?
This
For 2 weeks. For 2 weeks, one of the juniors, some of the juniors will be gone.
AP is
Okay.
almost impossible.
So, pause for 1 second, listen to others. Who, junior-wise, who's going to be gone this week? You, just you?
Oh wait, Alyssa will be gone too.
And I know she'll be gone, but y'all will be in advisory? Okay, so let's plan to meet today. I'm going to get together with you at different times if you're the only one who's going to be missing, and we'll talk about it.
I can come in the morning on the
Okay. So, yeah, we'll figure it out. So, guys, hear me clearly on this. The reason why, one, we're going to go over the study design, and I told Deacon this, I'm going to go directly over the things that you need to be thinking about and talking about in that paper. And you are going to do a revision unless you made an A. And I had one student who made an A on the paper, and they can revise if they want to earn over an A.
That's amazing.
So where's like a B?
So, say again? Okay, so, but listen, the biggest reason, and I'll go ahead and tell you all this, the biggest reason why some of us did not make A's, well, there's several things we need to talk about, but you have got to think about the statistical vocabulary that the AP exam is going to ask you to use. Deacon was asking me before spring break, hey, when are we going to start a review? That's what this project was. If you're having to reflect on these studies, you know what you're going to see on the AP exam, both on multiple choice and free response? They're going to give you studies, shorter than the ones I gave you, but they're going to give you studies. And they're going to ask you to analyze and identify the experimental units, the things that they did to reduce confounding in an experiment, the things that they did to reduce bias in an observational study. This project was that review. And so we need to do it, we need to do it well. And I want us to earn higher grades. So let's make sure that that happens. All right? It's not as a punishment, it is a, I want better for you. Okay? The second part of our review is going to be through a new project. This new project is not going to be a solo adventure. It is going to be either in groups of 2 or 3. I'm not going to decide it. I'm going to use a random number generator, or a random group generator, because that's the only way to fairly do things. As we all know, right? Only way to do it is randomly. Okay. So you have the instructions in front of you. And so what this project is this. And I'm going to get some examples for you to see. This project, which I'm going to admit this, I stole it from somebody. It's good. But you are going to conduct a study, specifically an experiment. And so what are you trying to establish in that experiment?
Cause and effect.
Cause and effect, right? We want to establish some kind of cause and effect about what? What does the direction say? We're trying to establish cause and effect between what two things? So it's something about which type of bias? Response bias. And so what things can cause response bias?
Who's asking the question?
Okay, so who's asking the question, right? What else?
How the question's being asked.
How the question's being asked. Is there anything else?
Who you're asking.
Who you're asking, okay? And who's answering. So look at, there's some bullet points there at the very top, right? There's some examples, right? Can the wording of a question create response bias? Does providing additional information create response bias? So that can be the wording of the question. Does anonymity change the response to sensitive questions? Things like that. And so here's what we're going to do with that. Your proposal as a small group is just due Friday. That way, I can give you feedback on your proposal over the weekend and email it back to you. So proposal, that's just the study design. So that's the question that you're asking, how you're going to approach that. And so again, this is going to help us review some of the experimental design principles. So what's the issue that we could run into with this experiment if we want to establish cause and effect? Confounding, right? There could be other variables at play that we cannot account for, okay? So what are some of the things that you need to think about in your proposal, in your study design to reduce the effects of confounding? So think about it. What do you need to do in order to reduce those effects of confounding? What are the study design elements that we've seen? That needs to be random, what? And we need to be careful and clear on this. And so this is again part of our review. We need random assignment for an experiment, not random sampling. Random sampling reduces what? Bias, reduces the effects of bias. Random sampling, some form of random sampling, reduces the effects of bias. But am I concerned about making an inference about a population here? So do I care about bias? No. What that means is we may have multiple treatments and we randomly assign people to those treatments. And you think about how you're going to do that, right? So is it okay for you to have volunteers for this study?
Yeah.
Yes. We don't care about making inference about the population. We only care about cause and effect. So can you have volunteers? Yes. Is it okay if you don't randomly select people? Yes. But random assignment is important. We'll talk about why soon. Okay, so random assignment. What else can allow you to reduce the effects of confounding?
Blocking.
Okay? And so blocking is a part of that random assignment. We're going to come back to that in a second. Say again. Replication. Is that what you said? Repetition?
Yeah.
So replication, right? Are you going to do this study with just one person?
No.
No. Do you have to do the entire study over multiple times?
No.
You just have to replicate with multiple people in the sample, right? So we could use random assignment. We can use replication. What else? We need to think through these things.
Random selection.
So remember, random selection is going to reduce the effects of bias, and we're not concerned about bias with an experiment. What else?
Control groups.
Should we have a control group? Maybe a question that we don't think would introduce response bias, and to have something to compare against. You always want something to compare against, right? So try to maybe have a question that about whatever you're trying to do that is not you don't think will introduce bias, or confounding. Control groups would be great. What about, and this is a big one that a lot of us did not talk about accurately, what about direct control of potential confounding variables? Right? Are there things that could affect the response that you're not really testing? Let me give you an example. Sorry, let me clarify and answer this. I want you to think about this. If your experiment is focused on the wording of questions, but you have different interviewers asking the questions, do you know if it's the question itself or the person asking the questions that's causing the response bias? You don't know. Remember, that's the idea of confounding. So what could you directly control? Yeah, who's the interviewer? Like, that's what we want to recognize is those things that could all, like, if I'm only concerned about, hey, how is the question worded or what extra information is given, would that affect the response? Well, then I don't want to change the interviewer. That could introduce a level of confounding. Does that make sense? What's your question?
Where are we gonna get sample sizes of 50 without interrupting classes?
That's really easy. You could just send
I
out
would say
emails to
lunch.
teachers and then make sure. To really eliminate bias, you could also have it say, if the whole
There's
classroom
not a
doesn't do
crowd
it,
program
then...
meal lunch.
Okay, you could also do it during advisory.
Well, I mean, if it's groups of 2 or 3, it's.
Right.
It's
I would say, so, well, now, just remember, we want to think about, like, that idea of, like, what type of response bias are you trying to measure? So again, we have advisory, you have before school, you have after school, you have lunch, you have lots of options to collect this data. Now, the proposal is the only thing that's due on Friday, right? Actual data collection and analysis will be the following week. Okay, so you have time, and you will have other people to work with to help with this. There's a rubric on the backside that we will use, or I will be using to score. Please notice that you will need a just a flimsy poster that may be the size of the dot plots we have around the room with the information included, right? It doesn't have to be beautiful, but it does need to carry out the elements of study design, and it needs to have analysis of the data you collect. What are the things that you need to include when you analyze data? See, this is going to help us review the second unit we did. So we do need to have the correct vocabulary, but what are the things we need to analyze when we analyze data?
Well, I think for this, like, shape and spread and stuff won't fly, so.
This is the word.
Sorry you feel that way. But it's going to help you learn, not you.
Okay, I had like something about.
Yeah. Look, but it depends on the type of data you collect. If you collect numerical data, could you look at shape and spread and things like that?
Yeah, but
So-
I don't think this is something you could collect numerical data.
So you're thinking more categorical.
Yeah, so in this case, you probably just have to like talk about what you found, so you can discuss a bunch of percentages.
So we might be looking at some percentages, things like that, some
Yeah.
proportions maybe. But you can still make graphs, right, with those things like bar charts, segmented bar charts, things like that.
Yeah,
So we still want that. We still want to compare and contrast mosaic plots. Remember, those are on the AP exam now. Bryson, do you have a question?
What is it that we're looking for?
If you look at the very top, right? The project. Your small group will design and conduct an experiment to investigate the effects of response bias in surveys. So you are going to look for, you could do one of those questions that's below, like, can the wording of a question create response bias? So you are going to create an experiment, or you could create an experiment, where you change the wording of a question to see if it introduces response bias.
and we have to conduct.
And you will
the way it's
conduct
gonna be
that
done.
survey.
Okay,
Well, you'll conduct the experiment, which will include a survey.
yes, sir,
Does that make sense now?
yes, sir.
Okay. And ask all the questions you need to, but we do need to get moving, so come in during advisory, things like that. All right, let's look at groups for this project.
If I don't like my partner.
I didn't ask.
We should do like a trade, we could have like a trade program though, for like the draft music.
Oh, wait, that was
I'll
so
do
funny.
that.
That was so
Yeah.
funny.
Me
And
the
first-
person.
Of the 2024 stats project draft.
Sorry, no.
Okay,
There we go.
Oh.
Has to be groups of 2 or 3. All right.
I don't
First group,
I don't
me,
like.
you, and
I don't
Alyssa
like
got
it.
together.
Okay, that works.
I don't like
Those are good groups. Very balanced.
it.
Those are people you can work with. Okay? So, what is due by Friday?
The proposal.
The proposal. So, At the end of class, I'll give you a minute or two to exchange numbers if you need to. But these are your groups. I guess I need to take a picture so that I remember these groups.
You don't have to.
I mean,
You don't have to remember.
That's not fair.
alright. Listen guys, there will be a check-in with groups as well to just make sure that you are actually actively working. Guys, the whole point of this is it's going to help you review elements of experiments. You have to think through what are you going to do to make sure that you establish the cause and effect that you want to see. This will help you review how to analyze data, how to write about data, and so I need us to take this seriously as a part of your review. It's not just a project to do a project, it's to help you prepare for the AP exam. Okay? So, I might look over the rubric, the things like that. You could ask questions about that tomorrow, but we have got to get going with today. Alright, so, we are on AP Unit 6, Inferences for Categorical Data, all about proportions. This is going to be Chapter 8 and Chapter 9. Now, quick question, did I give you the notes for Chapters 8 and 9 already, or just Chapter 8? I think I gave you both as well.
You did.
In preparing for the next couple weeks, I reflected on the notes that I have given you, and so I did edit some things. I did the Frere models, updated those from previous years. So I'm going to pass out some supplements at times to help us learn this content even better. Good one. Sorry.
You said supplements?
Yes.
I only got 8.
You just got 8? Okay.
Also, aren't you supposed to be doing hair?
So,
Yeah,
we'll figure it out.
Here on Monday.
Yeah, Austin, did you ever send that picture to me?
I sent it to you like 3 weeks ago.
Let's go.
Okay. It's really low quality because I sent it like last minute because I thought I'd do it that day. And then 3 weeks ago. So.
Curry.
It has no.
It's just a random.
I'm white, I had to take this, man.
Alright, go for it.
Amen.
I don't think I would be freaking out.
Yeah, sorry, it's a really bad picture. Just find it online. There you go. Good job. So this is my hero. His name is Jesus Christ. He literally died for me, so that's pretty cool. Kind of died for all you guys too, if y'all wanna accept that. But it's pretty dope, you know. Gives you some more time. Yeah. That's about all I have. I don't really prepare much.
No, I think that's great. Thank you, I appreciate it. Sorry, Aaliyah said she doesn't have these notes because you were here when we started, because you were here when we did the globe tossing, right?
Yeah, she was.
So you have
No, I
the notes.
wasn't.
You have the notes somewhere. I can try to find them
Hopefully at
and print it out
home
later.
then.
Alright, so,
Yeah.
Is that it?
alright,
Well,
quick recap. Huh?
I have 9 to
Unit
9.
6, inference.
That's.
Oh,
unit
here's
two.
my.
Okay.
There's 9.
You have them somewhere. We gotta stay organized with this stuff. But you have them, and let's talk about this. Let's get going. Chapter 7. Does anyone remember what the major topic for Chapter 7 was?
Confidence.
That's what we're about to go into is confidence intervals, which is built on what Chapter 7 is all about. We're on Chapter 8. What was the last test we took?
We don't know that he has.
Say it again.
Sampling distribution.
Sampling distributions, right?
Yeah.
Remember, a sampling distribution is built out of having a what? We did with the pennies back there, the big one.
Distribution. You have to have all of the top.
You have to, guys, remember with a sampling distribution, it is built out of a population, right? And then we looked at collecting multiple samples from those populations, right? And so what we discovered was that the mean of all my sample means was equal to what?
The population.
Population mean. Remember, the mean of all my sample proportions, right? The mean of all my sample proportions possible was equal to the
Population.
population proportion, right? Remember, the mean of all my statistics. Logan, you with me?
Yep.
The mean of all my statistics should equal the population or the parameter value. And so we also discovered the standard deviation of the sample means was the population standard deviation divided by the square root of n. And the standard deviation of the sample proportions was the square root of p times 1 minus p divided by n. And what did we learn about shape? When were the means approximately normal, the sampling distribution of the means?
If the population is normal, or if the, is sufficiently large.
So remember, if the population is already normal, the sampling distribution is also normal. And if the sample size is sufficiently large, the sampling distribution will always be approximately normal. What was that sufficiently large size?
About 30.
About 30, right? And that's called the not large count so close,
The
central limit theorem. So we gotta be careful, right? So we gotta commit this. So, Bryson, central limit theorem, large counts was for proportions. Large counts was that n times p has to be greater than or equal to what? 10. And n times 1 minus p has to be greater than or equal to 10. So that's expected successes, expected failures need to be greater than or equal to 10. And if the large counts is satisfied, the sampling distribution of proportions is approximately normal. So we got to remember large counts versus central limit theorem. Okay? All right. And so, and Bryson, we got plenty of time to learn this. Again, guys, remember my focus is that we learn it. You don't have to learn it right away. All right. I need to get rid of this logo. I'm distracting myself. All right. So here's what we did. And here, so here's the issue, right? So how is this chapter different from chapter 7? Chapter 7, we assumed we knew the what? The populations and the parameters. But how often do we actually have the population? Almost never, right? Like that defeats the purpose of statistics. So how is this chapter different? Well, this chapter, we're going to use samples to make predictions about the what? Population. We're going to use samples to make predictions about the population. That's the key to this unit. This is what statistics is all about. This is what all the buildup has been to. This inferential statistics. What's up?
I'm not like, but like, didn't we do that the first unit? Or was that what we did, or no?
Ish.
I was just wondering.
And you're thinking of unit 2, and we collected statistics. In last unit, we did look at sample means, we did standardized scores, but we didn't do what we're about to do here. So remember, the whole thing is, we started this last week, or the week before spring break, where we tossed the globe, right? And what was the data we collected? I hope someone wrote it down, because I didn't.
It was something like 70%.
So let's see. Hold on, I thought I just saw it. Didn't you have the actual data?
Oh, yeah, it was on there.
Yeah. Go back to that
She
data.
has like her own little thing, and she was writing something else. And she has the sheet with all the stuff on it.
Yeah. So what we did was we collected this data. Group 2 had got the water being about 66% of their throws. Group 3, it was 0.704. Group 4, 0.72. Group 5, 0.6785. Group 7 was 0.6 for a total of 97 out of 146 for 0.6644. So what we decided, or what we think, is that 0.6644 of this globe, that proportion of this globe is covered by what? Water. Right? That's the whole idea here. And so what we need to recognize is, oh, I completely butchered that and forgot to update it. It shouldn't say white beads in the bag because I changed that activity. So here's what I want us to do with these globes. The question is, how confident are you that that value, that 0.6644, is the true proportion of water on the globe?
Not at all.
Why not confident?
I mean, I already know that they said. Are we talking about like specifically on these or like on Earth? Because like this.
It's a great question.
I don't think.
I'm going to say on these globes for now. We're going to talk about on Earth in a second.
This doesn't.
Okay, on these globes.
Say again.
This doesn't count for rivers. Like whenever we land on land.
So let's just focus on the true proportion of water. So let's just say But like,
Yeah.
let's just say ocean water,
Also,
and that make that easy. So that's a good thought. But I'm just say ocean water, make our lives a little bit
You
easier.
gotta think about it, everybody has like different opinion, like sizes.
Okay,
Yeah.
okay. But
Throw it off.
It's only 3% of 30.
hold on, just let's focus on the statistical reasoning though.
Okay.
Ashton.
It's a continuous type of value, so the chance of it being one thing is 0. But the chance of it being within a range is like existing.
So remember how we looked at continuous random variables and the probability of getting exactly that thing? What is that probability?
0.
So the probability that x equals 0.6644, that probability is 0. When you have a continuous random variable, the probability of getting exactly the thing or getting exactly the mean, that likelihood is what? 0. So, what does it say here next, right? And that's the statistical thing we want to recognize. What's the likelihood that we actually got the population value? Pretty low. In fact, I was already showing this to Deacon, so Deacon, come up here real quick. This represents the true proportion of water, right, that is on that globe, of ocean water, right? Here is our sample proportion, our statistic, right? It could be here, right? Could be here. Could be right here. I know it's going to make Deacon really uncomfortable, which is why I'm doing it this way. It could be right here, which means I perfectly hit it, right? It could be over here. Could be over here. Now, has that true proportion moved at all? No. But our statistic, our sample proportion, is somewhere around it more than likely. It's very unlikely that it's right on there. Does that make sense? Okay. However, and that's because this is called a point estimate. It's a single value. You said something about an interval earlier, right?
Yeah.
What were you saying with that interval?
Because I was saying, like, there's an actual chance of it being within the interval because this is a continuous value.
Okay, so could I like take my point estimate, make it in the center, and like, I don't know, make an interval around it to try to capture that true proportion?
Yeah.
Because would that capture it?
Yeah.
Yeah. What about now?
Yeah.
Mhm. What else was over here?
Yeah.
Mhm. Okay, so we don't know what the true proportion is, but what are we going to try to do? We're going to try to estimate it to, what was that word I said with a C? Capture it, right? Remember, I want my interval to capture it, okay? So here's what I want you to do. I want you to think, not just make up stuff. I want you to think about using the statistics that you know, create an interval of plausible values for the proportion of water, of ocean, let's say it that way, on the globe. So create an interval of plausible values. So I want you to consider the fact that we know that this is P hat, right? P hat is equal to this. I want to create an interval using statistical reasoning that would give me an interval that could possibly capture the true proportion of ocean on the globe. I want to give you just 2 minutes, talk about it in your groups, think about what you can do, and we'll come back together.
How would you write it?
What do you mean?
Like you just write it could be from this range to this range.
Yeah, so we'll actually use interval notation, like domain and range interval notation that you learned in your math classes, something like that, okay? But think about what statistics you know that you can use to find a reasonable set of
Brighter
values.
than the rest of them, what size that it wants to be.
Yeah.
So I'll say this, that's good thinking, but the IQR was something for numerical data, not proportions. So what's another measure of spread that you might be able to think about? What do y'all think?
So, oh, those are G's. That makes a lot of sense. Like the G, like say like G2, it looks like.
Yeah, so the mean, so remember, because we're not dealing with mean, we're dealing with what? Proportions, right? Looking at it, what do we say about the proportions that can tell me, I don't know, maybe, so like when I think, so like here's my point, here's my first time example proportion, right? But I kind of want to get outside that level, stuff like S word, like maybe, I don't know, describe outside of that one.
There's always sampling variability.
I mean, can't we just put the 20
First 100 and can you?
So shape isn't going to tell me how far out to go.
Or like,
Standard deviation is a measure
But
of
you never
what?
know if our samples are low. It just happens.
It's a measure of. It starts with, oh, it's a measure of spread.
yeah,
Can we find the
but
standard
like,
deviation here and use that as a measure of spread to try to
It's just
create
crazy.
intervals?
Science.
So think about how you find that measure of spread.
Alright,
So what do you think?
Our interval.
I don't care what you say, it's just science.
I don't think this has a scale, which means that, like,
So why those numbers?
yeah, but like every math has a scale.
Yeah,
That's what statistic is.
So you went how far?
I don't know, 'cause you gotta,
He's actually
like, there's some globes
Okay,
that have
so you would
Africa
do
like
0.4,
really small, and some globes have
6,
Africa like
Just one of my
gigantic,
favorite teachers.
So you-
depending on how it is.
So you went either direction the same
I
time?
don't know if that.
Okay.
Russia looks really.
Trust.
That's cool. Cool.
But
But why 22? What is that?
No,
that looks about right.
But Africa's much bigger than that.
But if you tell second history,
You don't understand how big.
you would go
Actually,
crazy.
we gotta just look at each
History would-
individual column square.
The middle
Where
class.
the.
Not just like,
Down.
It's just,
No,
yeah,
so
stuff
did
on
they
the
use
top
those
and bottom
colors? I
is
like
the
that.
rest.
Well, I mean, I
It's
just.
stuff in the middle.
Let me ask you this, we're trying to like,
I know.
I don't know, go outside of it, right? Like we're trying, we have a point estimate, like a sample mean is kind of in the middle. But what's the thing that allows me to, I don't know, like go around it, like, I don't know, measure how much is around it.
Honestly, that's like digging up dead bones
I
or something
think,
to make sure.
What measures,
This ain't happen, Captain.
The area.
This ain't happen, Captain.
so here's my data
For
point.
like all.
It's gonna measure how far those data points are from that piece.
Could do the.
Standard deviation, right? So what's gonna measure is the typical
So
distance from the proportion.
Mr. Carey, that those are inaccurate.
Find the standard deviation somehow. Think about that. Use those formulas that you have. Yes, an interval just like
Well,
anything
there's
else.
flowers blooming in Antarctica. That's my favorite quote. There's flowers.
Hey, Mr. Kennedy, do you have another
It's
formula?
just saying something that's.
What?
Do you have another formula sheet?
Yes, somewhere.
I mean, right here.
Alright,
Part of Greenland.
so hold on, and I'll get to you in a second. So let's talk about it. So, first things first, I want to talk about what one group said. One group said, here's an interval that they felt was plausible. Notice this interval is written literally using interval notation that you have seen in every math class up to this point. There is one great detail about this interval that I want you to think about. Does anyone recognize, so Logan, hold on a second, I need you to notice this detail.
Parentheses.
Okay, not just that, yes, parentheses, but there's something else that's important about this sample proportion that we got.
it's an even range with the, like the estimate in the middle.
So that estimate's right in the middle, is that what y'all plan, Lexi and Melina? Notice, what is directly in the middle?
Yeah.
The p-hat, right? That point estimate needs to be where? In the middle. And we're going to spread out from there. Remember how I extended my arms and I tried to capture the true proportion from that p-hat? Okay, so that p-hat needs to be somewhere in the middle. That makes sense, doesn't it? But these two groups, y'all talked about something when I was over with y'all's groups. What did y'all talk about that might help us find out how far to go out?
Standard deviation.
Standard deviation, oh yeah, so we're looking at how spread out it is, right?
Yeah.
Yeah, so how do we figure out how far to spread out? We look at the standard deviation. Oh, okay. Well, let's look at that. So I'm starting at 0.6644, and then I'm going to add or subtract, right? Because I'm starting there and I'm going to both sides.
Yeah.
And how much am I going to add or subtract?
I'd say 2 standard deviations because they cover about like what 95% of the day.
Oh, look at that. What's Ashton referring to there when he's talking about 2 standard deviations is roughly 95%? Oh, the empirical rule, right? So if I go 2 standard deviations to either side, roughly 95% of that data is going to be captured, right? And that gives me a pretty high chance of capturing the true proportion. That makes sense? So we're going to add or subtract 2 times. We're going to talk about what that 2 is called later. But the standard deviation, how am I going to measure the standard deviation when I just have a simple proportion like this?
Standard error.
Can we just use a formula?
There is a formula, and what's the formula called, Josh?
Standard error.
Standard error. We've used standard deviation up to this point. What was the standard deviation of p hat?
Should be P times 1 minus P divided by N, and the whole thing is squared.
Hey, does anyone see a problem with using that formula though?
You don't have.
Oh, we don't have P.
We don't have p. Oh, so can we use that standard deviation formula?
No.
No. But Josh, on that formula sheet, you found another formula, didn't you? Under standard error, is that what it's called? What was that standard error formula? Did they use SE on there for standard error? Or just S?
S.
They use S? And so it's S sub p hat. Notice, right? Is that the population standard deviation? No. That's a sample standard deviation for those sample proportions. And what's different about this formula?
You use P hat.
It uses p hat instead of p. We don't have p, but do I have the sample proportion?
No.
Is that going to be as accurate as having the population proportion?
No.
No, which is why it's called a standard error and not a standard deviation. But that's a measure of how spread out, or that's an estimate of how spread out the sampling distribution would be. So,
What's P hat? Wait, what's on P hat for this?
sample proportion that we calculated earlier, right? That 0.6644. Remember, that's also going to be the center of my interval. And what was my sample size? Was it 146? Okay. So find out my standard error for me. Say again. What?
You just right over everything else.
Does that make you feel better?
Oh, it was not.
Alright. Can you grab one for Peyton as well? So, guys, come on. Y'all need to practice calculating these standard errors. Don't just let one person do it. Everybody should have a calculator in hand. Go for it, Bryson. But also, pick up that calculator. I have formula sheets printed out.
I wrote almost all my notes in the wrong way.
There we go. I knew I had some.
P hat.
I was 0.
All right.
And then what's that? And then 146?
146, remember that was my sample size? We did 146 total.
All right, I got a number now.
What you got?
0.0391.
Alright, so let's find our interval. So notice I did 2 standard deviations to either side of that point estimate.
All right, so the number on the right, I had 0.7426.
Notice how we did 2 times that standard error right here?
And then on the right, 0.5862.
Is that right?
Yeah, I meant left, but yeah.
That's what you got as well? Sweet. Quick question, does anyone know what I would get if I were to average that minimum and maximum to the interval? The what? The p hat that we originally had, right? Because what's in the middle of that interval? The p hat, right? Like that's the starting point. You did it?
I did it.
You did it! That's what I like to hear.
Good job.
So,
Yeah.
realistically, so I do want to point this out, realistically, does anyone know what we could have done to make a smaller interval and maybe hopefully get a smaller set of values that could have giving us the true proportion of ocean on that globe?
Get a larger sample
The
size.
actual proportion
So getting the actual proportion would be tough, but
yeah.
if I increase this sample size, what's gonna happen to the standard error?
So, yeah, it's gonna decrease.
Because if I increase what I'm dividing by, right? If I divide by 1,000, isn't that gonna make the overall thing smaller?
Yeah.
So that's what we would want to notice is one thing to make our intervals smaller and more accurate, or precise I should say, more precise, is to use a larger sample size. I think in the future I might do that actually. But here's what I want to ask you now. So what does this mean? What is a plausible interval for the true proportion of ocean on the globe?
Somewhere between, man, I gotta read all that out. Somewhere between like 0.5862 and 0.7426.
Anywhere in between there is plausible. With roughly 95% confidence is what we'll call it, because we use 2 standard deviations. We're going to go into more detail about that in a second, but here's what I want you to understand before we move forward on this. What is the actual amount of water on Earth, roughly, in terms of oceans? Huh?
3%.
Close.
Should be 70%.
71%. I only know because I did Google it last night just to make sure I was right. 71% roughly. Did we capture that true proportion of 0.71?
We did.
Yeah.
We did, right? Now I will point this out though. If I had increased my sample size, which I have done this in the past with an increased sample size, I actually don't capture that 0.71. And if you actually look at these globes, and we did more sampling with these globes, the true proportion on these globes is not 0.71. Any guesses why?
Because it's.
Do you like, how do you calculate the true proportion?
They're not the same.
Was it because they're shaped like a ball?
Well,
It's,
if you're giving this to a child, how much do they care about the ocean?
Not at all.
Not much. So what do most globe makers do? Especially with cheap ones like this.
They stretch and sink the con.
Yeah, they actually like expand and make those continents a little bit bigger, which means that there's more earth and less water. So what would I consider this if I was trying to use this globe? It's what?
Bias.
Oh, it's bias, right? Like this actually is not a good sampling measure. Now, was there randomness involved? Yes. Where we caught the globe was random, so that's okay. However, this is not a good source to use. It's measurement bias. That would prevent me from making an accurate inference about the population. Now, just because this interval captured the true proportion does not mean it always would. In fact, it usually has not, because I think I've done a bit larger sample sizes in the past. What you could do is there's actually a Google Earth thing where you can randomly select points. And I've done that with students in the past as well when we had more time. Go for it, Logan.
Like those big spinning globes, would that also be biased too?
That's a great question. I haven't ever looked at those. I don't know. I just don't want to tell you yes or no. I think those are designed to be accurate.
No,
But I
aren't the
don't-
spinning globes because the globe can't. Oh wait, no, it's a map. Sorry.
Yes, the map would have problems, but the spinning globes I think are accurate. Anyways, let's get back to the statistics that we're looking at here. So what is the logic of confidence intervals? What should we write there?
Generally, the true proportion value will be within 2. The parameters should be within 2 standard deviations of an unbiased estimator.
With 95%.
We'll go into a lot of that, so hold on to those ideas because we're going to go into more detail based on an apple and stuff. Y'all are definitely hitting close on. Here's one thing I want to caution you all and need you to pay attention to this. When Deacon was up here, did the true proportion ever move? So the true proportion is not within 2 standard deviations of the sample proportion. The sample proportion is within 2 standard deviations of the true population proportion. It's important because the AP exam is very particular about that language. And we don't have P, so we use the sample proportion to estimate. Okay? And so be careful about that language. The sample proportion is hopefully within 2 standard deviations. And we use other measures as well. We'll look at what those are soon. But the sample proportion is hopefully within 2 standard deviations of the population proportion. We're going to look into Applet in a second on the computer that will help with that idea as well. Okay? So the logic of confidence intervals, one of the biggest things we need to recognize is this. How likely is our point estimator to perfectly hit the parameter? Yeah, it's very unlikely, right? So if the point estimate is very unlikely to hit the parameter, what do we need to create? We need to create an interval that can capture the parameter. That's the logic. The point estimate is very unlikely to hit the parameter, so we need an interval that can hopefully capture the parameter. That's the key. I would have that written down. Okay. The next set of notes, while you're writing it down, I'm going to pull up the textbook to answer some of these questions. Hey! So, by the way, I got y'all a different color sheet of paper so you could do the fair model more easily, hopefully. I didn't have any more of the blue, unfortunately, but we'll make it work. Alright, so, section 8.1 from the textbook, confidence intervals. These are the basics. Before we get into the weeds of a lot of things, we need to learn these basics well. Notice here, a point estimate is a statistic that provides an estimate of a population parameter, right? A point estimator is a statistic, right? And so notice the difference between the language of a point estimator, that is just a general statistic. What's the value called?
Point estimate.
Point estimate, right? So p hat equaling 0.6644. P hat is my what? With using that vocabulary.
Point estimate.
That's the point estimator. That's the statistic. So 0.6644, that is my,
That is the point estimate.
that's point estimate, that's the value. Okay. Notice the logic behind the language is right there to the left, right? A statistic is called a point estimate because, it represents a single what? Point on a number line. Mathematicians, statisticians, we're not original. We name a thing what it is. What page does it say to go through on the...
36 through 58.
And so, and here's the major idea of a confidence interval, right? They give an example here. And so one of the big things with the confidence interval is where does this come from, this information right here? It comes from the sampling distribution of that point estimator, right? And so remember how we use the standard deviation, or in this case the standard error formula for a sampling distribution. We have to recognize that this formula does not come from the point estimate itself, it comes from the sampling distribution. So we use our understanding of sampling distributions that need to be approximately, what again? There's an N word. Approximately normal to use that empirical rule that Ashton was talking about earlier. It has to be approximately normal. And so we're using the idea of the sampling distribution to help us get there. Notice there's also an example above this that we can use. Yeah, notice how confident should you be that a point estimate is correct? That a point estimate is correct?
0.
Oh, 0.
Yeah, the point estimate is a single point on an interval, right? It's very unlikely that it's correct, right? So how can we do better by creating an interval, right? Those are the things we need to notice. Obviously, this was supposed to be what we did before spring break. All right, this is where we're supposed to pick up. This is each of you. Actually, as a small group, get out an iPad, or if none of you all have an iPad, get out grab a laptop from the back.
My iPad is dead.
This is one of the supplement things that I decided to do. I'm just gonna pile these up for now and collect them at the end. Run like a wind bullseye. Look, I'm gonna start without you if you go.
Can I go too?
Actually, let me give these instructions first, Deacon, and then you can go.
I don't know if school can afford new MacBooks, but these will be they're about to blow up.
So guys, the where you need to go is on the sheet of paper that I just passed out.
Well, that's all I think about potential fire.
Oh, they definitely are.
They're burning.
These literally are burning.
These are overheating.
I don't even know how they're not even on.
No, it's probably illegal.
So notice guys, there's a tiny URL there. It should take you here.
Because they're all restarting, that's why.
Oh, that's nice.
But remember, you only need one device per group, guys.
Yeah.
Oh. I thought you were
Well,
supposed
it
to.
wouldn't be any help if the device wouldn't be
Okay, good.
working.
Guys, you only need one device per group. Okay.
These are bombs.
I believe so.
Okay. And so we should be seeing this right now. I'm going to give these instructions so make sure you're engaged in the following of the instructions so that certain people can go use the restroom and the rest of us can get started on this activity. But it says, right, use the confidence intervals for proportions applet, set the population proportion to 0.5. There we go. Confidence interval to level to 95% and sample size to what? 75?
It won't let me enable the,
Okay. Okay, if that's not working, go to,
Mr. Kenny,
hold on,
you just on purpose.
what?
The freaking link redirects to never gonna give you up.
What?
does it really?
Did you do CI or CL?
It's right here.
That is not, you typed something in wrong.
No, I did the same thing.
You rickrolled me.
What did you type in?
You just got rid of all.
I typed in.
Because I just clicked on the link.
www.tinyurl.com/applet.cl.
Mr. Kenny.
Oh, sorry, that's a CI, guys.
Wow.
Confidence interval, notice.
Massive rickroll.
It's a capital I.
Rickrolled you, that's crazy.
To like have that direct.
I was like, wow.
That's so wild.
That was so
So
Dang, one letter off.
Wait, it wants to take me to another place. I don't know
that's crazy.
It's probably so many.
Like
Everything correct.
That's true.
Oh my god, you know, fell off one of the rides at the fair. Like, it literally went through the hole in my pocket.
So guys, look, if it's not working, if you just search confidence interval proportions applet, it is literally the first one up there. Confidence interval proportions applet.
He will never live that down.
There we go. That's what you should be looking at. Okay. But here's what I want y'all to see. Please notice right here, in green is the true proportion 0.5. That's the reason why it's in green right there. And so what you're going to want to do is you're just going to hit sample. Notice there's an interval up here. What is this 0.427? That's the what? It's right in the middle. So it's my sample proportion or my point estimate. And then what is this? That is the, starts with an I, confidence interval, right? Did that confidence interval capture the true proportion?
Yeah.
Yes. Okay, sweet. Did that one?
Yes.
That one?
Yes.
Oh, that one missed it, right? So follow the directions on there, on this sheet. No, on the sheet. Well, we'll figure that out in a second. Yeah, follow the directions through number 2, and let's do 3. Yeah, you should be able to do through 5. And then we're going to come together to interpret the confidence level. So, answer the questions 1 through 5. We're going to come together to talk about the confidence level. Yes. Make sure your, hey guys, make sure your sample size is correct.
Sorry.
I was about to say.
Yeah, it might be tied into that.
Sample.
You can go ahead and go. We don't actually get a device, or I guess you'll just.
Oh, my line.
Yes, that's what
Josh,
I'm.
I'm not getting onto you, I was asking
Oh,
about the device.
in the middle of two stabs.
Now, what y'all could do is you could set it here so all three of you can see it, or one of y'all can grab a Mac house.
Who paid money?
Are y'all completing? So what I would do is I would just go ahead and do my 10 samples. Is it really just hitting the button 10 times? So remember, you don't, hey guys, you don't have to have a super lot of detail, just focus on which side of the true proportion the interval is and roughly how spread out it is. Really focus if it misses the true proportion at all.
You know, like, it's like that one picture, it's that cartoon, it's like two mining, and like one of them turn around, but like now everybody uses it, like say, you know, like, one more part, like.
I can't get a lot of it. That's so funny.
Oh, for real? You want it?
No, I
Freaking
don't,
hilarious.
I don't, but, of the two guys, and,
Charge my phone, but I don't have a lock.
Yeah.
Laptop, so it's okay.
Go ahead and extend those out quickly and efficiently, just showing if it captures the parameter or not. Did all of y'all capture the parameter?
I should have done
Hey, do this for me. Put a color on that. There should be some color marker or something, just to make that one stand out, so that we notice that it's different. Here you go.
Yeah.
There you go.
Here,
That's down.
narcolepsy? Narcolepsy. No, I do not have that either.
Yeah, sorry.
Alright, let's use that to draw. You'll notice that these two reds miss. And these are the two intervals that miss. Very, very close, but still miss.
So it's her.
Wrong one.
So,
That's good.
just, here, just use this for your 10 right there, and then start doing the sample 25.
I just.
I meant how many, like, times you
I did that. Is it any of those people?
Yeah, it says just go 100. So, and you did it 100 times, right? And what percent hit?
75.
Oh.
Are we just drawing it?
Because that's only 25 of the 100.
Yeah.
Oh, okay.
And so it recorded the total percent hit right there. There's a what? Oh.
Oh, I meant to wait too.
It's really okay. As long as it's clear which one's hit, which one didn't.
Sample 25 was actually
Yeah. And 4 times. Alright, and so if you make it brighter, you can see right there, what percent of those intervals hit? Now, notice there's 25 right there, and 2 of them didn't hit, right? But overall, out of those 100 intervals, 92% of them hit. Does that make sense? So I did it as a proportion though, I should have said that. Yeah, it says how many intervals, oh, how many hit, or how many capture. You can write that. Any thoughts yet on what that confidence level means?
Like it, just like it's very, just like, for some reason it's going to stuff, so it'll just be like 2 little blue lines.
The proportion of samples that will hit that will have
I think it's the number of standard errors that it is, well, it's directly related to the number of standard errors that it is. That a company should be able to exchange from like, pH increase.
Okay.
the population proportion. So it's
What is
95%
it, 8 out of 10? It is.
samples being reviewed.
I'm sorry.
Here's look at the first one, the rocket change driving.
Two
It's
cents.
It's like.
What's on something?
It's somewhat related. Let's do some more samples. No, it's no longer 95%. Say it again. So what is this measure though? How often that interval does what?
How often the interval captures the population proportion
So how often, oh, how often it captures it in the what?
in the long run?
So law of large numbers idea?
Yeah.
So like if you keep doing that, it'll capture it.
I guess it does the average amount.
Test out that theory.
92 out of 100.
Alright, so what do you think confidence level
So I
means?
guess Steve.
No, don't reset it. You should just get
No, I did 650.
That's perfectly fine.
Oh.
Keep going. What, so like right now,
Right, it's
0.92, right, 92 of them.
It's
What do you think that
covering at
confidence
93,
level means?
like,
But the confidence level is 95.
Alright.
Mhm.
So
No, confidence is.
How about we keep sampling?
What's the same?
it's the same number.
I know, but what's the number we're at? We did.
Okay. So what happens if you do more and more samples? What
This is-
percent?
Still can't believe you guys.
Oh, there's a.
What-
There's a rule. Why can't people
There's
do
a
that?
rule about that.
I don't see you.
Oh yeah, law of large numbers, right? As our sample sizes increase, we approach the
You feel
true,
good?
Yeah.
Right.
I mean, it's.
not
Yeah.
true proportion. So we have to keep law of large numbers, large counts, and central limit theorem separate. Law of large numbers says like as we increase our samples, we're gonna approach the true proportion. But true proportion of what? What are we measuring here?
There were so many people asking about it.
What is it, when they say
Are we
percent
measuring the
hit,
amount
what do they mean?
The amount that we're in
I'm gonna
that
pass
an
out.
area.
Yeah, but what is that by that? Like, what is that measured?
I think my sugar
So what
is too
is?
low right now.
Ah, so if the interval captured
Avocados
the
and I have
true
everything.
proportion.
Bagel season.
Okay.
But I woke up
So-
too late.
What you're saying is in the long run, you think what percent of this interval will capture the true proportion?
I can't check in.
Notice it's about capturing the true
Checking
proportion,
in.
right? The point estimates move, the interval can change,
But that costs us
but
$2.
that true proportion stays the same. In the
I
long
don't get a
run,
grade in it.
this
My mom
process
said
is
as long
gonna
as it's
capture
not
the
affecting
true
my-
proportion how often.
Like I don't get a grade in that class.
We're gonna discuss in just a second, but that's what we need to recognize. Alright,
It's
So what do we
getting
think?
A all year round, even if I'm not in there.
Okay. What?
why don't you do some more
What about just the first one?
Yes, it did.
Sample test.
And that is this.
And it's not
Like
70%
the
first
anymore,
one,
it's a little bit higher. Keep
And
sampling.
then reset and take total.
It gets to the true population.
Then it's the 99 out of 100 captured.
Which was our confidence level?
Because it's asking.
When we did
how
our
many
confidence
times
level at
out of
95% earlier,
did it capture the true
um,
portion?
didn't we get close to 95%
No, you just keep your
For the-
samples.
for the percent hit?
Yeah, I was just going.
Huh, wonder why this one's different. But we're gonna talk about that in a second, but I was just gonna point this out to you. When we say 95% confidence level, what happened 95% of the time? Roughly. Huh? But what does that mean? Like, think about what we're measuring.
Oh.
The intervals capture the, what are those intervals either capturing or not capturing? The true proportion, the parameter, population proportion, right?
Yeah.
So that's what we're talking about here is how likely is it that our intervals are going to capture the true proportion in the long
More
run.
like-
Notice, it's not every single time, did it? So, let's talk about it. All right, let's discuss this a little bit. So, here's what we need to understand out of this. I got a lot of the important ideas from different groups, so I want to bring it together. First off, did every interval capture the true proportion? No, it definitely did not, did it? But in the long run, when I had a 95% confidence level, so I'm doing quite a few of these.
is what we're getting. So we'll finally.
I'm at 0.93 right now, but now it's increasing a little bit. What did y'all notice or remember or think about? So I've only done 1,600 or so intervals at this point. If I continue to increase my number of intervals, what percent should capture the true proportion?
99.
We need.
Oh, wait,
Remember, this
95%.
This is 95% confidence level, right? So 95% confidence level. So as the number of samples, and what are we getting from those samples again? We're getting this is called an interval. So as the number of intervals or samples increase, the intervals should do what?
Approach to confidence level.
So the intervals should, but what are these intervals trying to do?
Capture the
There we go, right? These intervals, the whole point, they should capture the parameter, right? In this case, what is that parameter? What type of, there we go, population proportion.
Where are we writing this at?
It can go on that sheet.
Yeah, I know, but
Just, I'm kind of writing it in the margin.
Yeah, there should be a question about, oh, there's a question that says interpret the confidence level. And so these are notes about what that confidence level is, right? So as the number of samples increase, the interval should capture the parameter, the population proportion. How often?
95% of the time.
95% of the time. Why do we say as the number of samples increase though?
Because that's according to the law of large numbers.
Yeah, is that guaranteed in the short term?
No.
No. Percentages and probabilities are based on the law of large numbers in the long term, right? So we're not looking at the short term, but if we repeatedly select from this population, how often should our interval capture the parameter? 95% of the time. Okay? Now, so what if it was an 80% confidence level?
The same thing would apply, but it would just say 80% of the time.
Yeah. I know, we're going to talk about that in a second. So one thing I'll point out is this. The way we often will word this right here on the AP exam, because that, and this is what it says in the book, we will say in the long run. Isn't that literally what law of large numbers is all about? So instead of that language, we will say in the long run, the intervals should capture the parameter, the population proportion, 95% of the time.
Yeah, well,
Answer 5 is 76%.
So notice, I'm actually staying pretty close to 0.8. Did they change, have you changed the,
what'd you just call me?
sorry, my brain lag.
notice my percent hitting is pretty close to 0.8, Deacon. So why would mine be close to 0.8 but yours was 0.7? Sampling variability, which is why we need in the long run, right?
So if I did more samples, it would be closer to my end.
You can only do
Not
9,000.
Say again.
You can only do 9,000.
You'll try it all the way there?
Yeah.
So, there is a limit to what computers can do, but here's what I do want you to pay attention to. Watch this. Pay attention, because I don't know how many of y'all looked at number 4 heavily, but it said watch your confidence intervals as you drag the confidence level. So if I change my confidence level from 80% to 90%, does anyone notice what happened to my intervals? They got bigger.
Ding.
Notice, did my point estimates change?
No.
No, but the interval got what?
Larger.
Yeah, larger or wider. What happens when I go up to 95? They get wider again? Yeah. What about to 99%? It got even wider, because if I make that interval wider, what's that going to do? It's going to increase the chance of capturing the parameter. That's it, right? And so you remember earlier when I think it was Ashton talked about that too? We doubled the standard deviation or the standard error. We can change how many standard errors we use, how many standard deviations we use, to either make the interval wider or narrower to change the level of confidence that we want. Leah.
Is there like a limit to that? Because after each of us going so far, it's like we're just covering everything now.
Well, you still won't, so here's the thing. Can you ever be 100% confident? No, so there is always a limit. Usually the highest confidence level we'll ever use is 99%, but 90, 95, and 99% are the 3 most common confidence levels. But what we want to recognize out of this is, as we increase our confidence level, what happens to my point estimate? Think about my point estimate. What happened as I increase my confidence level? What happened to that point estimate? The point estimate stays the same, right? What's the only thing that changes? How
spread of the confidence interval.
how wide that confidence interval is, right? So to be more confident, we're going to make that interval wider, but there is a downside to that, right? If I have a wider interval, like,
It could be more points.
right, there's more options, right? Yes, I'm more confident, because here's the thing, we got to recognize,
That is saving.
more confidence does not mean that we're like spot on. More confident just means we're more likely to capture the parameter. And so we don't necessarily want a super wide interval, so you have to play against that and figure that out. So let's look at what it says here. So what is a confidence interval? Why do we use an interval estimate rather than a point estimate, confidence level, and how do you interpret a confidence interval? So let's look at these things based on the book. So pages 538 to 541. So we've already talked about these things with why do we use a confidence interval. Oh, we're not in chapter 9? No, we're close to chapter 9. Where's your chapter 8 notes?
My notes are the only thing.
Oh,
Why
that side.
They're backwards.
Got it. Okay, but we're over here. So, what is a confidence interval? Literally, it's a, what are we talking about? We're talking about a,
Which confidence?
so an interval that hopefully captures the parameter. So it's an interval of, the language that we used originally was plausible values, right? It's an interval of values that we think could capture the parameter, right? So, the confidence interval is an interval that we believe captures the parameter. There's a table there.
Maybe.
Maybe.
It just moved, don't worry about it.
Yeah, not sweating it. And so, Ashton, what you said with 2 standard deviations is exactly the idea that the book had of 95%, right?
Yeah.
Using the idea of 2 standard deviations is a good starting place. Is it what we're always going to use? No. And I will say 2 is not exact. Remember, the empirical rule is an estimate. We're going to talk about what it is exactly soon. But 2 standard deviations. So here's the definition of that confidence interval. They also have a note here. It's also called an interval estimate because it is literally an interval of numbers that is estimating something. So a confidence interval gives an interval of plausible values for a parameter based on And here is a key that we should add based on what? Sample data. Now, we're not pulling this out of thin air. We're not making stuff up. We are using our sample proportion, Peyton, to ID an interval of plausible values. Please notice that plausible is not the same thing as possible. Plausible means that it's something I'm not surprised by. Technically, and this is what you had originally, Tyler, what was the possible set of values for the true proportion of water on the globe?
0 to 1.
Right, like that's possible. Is it? No. Plausible is different than possible. So plausible is different than possible. Yes. Let me make one note, because I remembered one thing I forgot to mention earlier. Hey guys, one thing that we have to pay attention to. This one thing I forgot to mention earlier. Right here. Let's say I make my population proportion 0.2, and I make my sample size 30. And I'm going to make my confidence level 95. That's not the one I wanted. Where is that one? Well, hold on. I should be running into an issue that it's not giving me. There we go. Notice what percent is actually hitting this time around? 0.83? Definitely not 95%. Anybody know why?
Because it's not normal.
Because what?
It's not normal.
So it ties into the idea of a small sample size and it's not normal. Notice, would this population proportion and this sample size satisfy the law of large numbers? No. So would I have an approximately normal distribution based on our assumptions? No. So could I use a confidence level or a confidence interval then?
No.
Notice that confidence level would not hold up if we do not have an approximately normal distribution. That is an important thing to notice. Your sampling distributions have to be approximately normal for confidence intervals to work. So I'd make a note of that. Okay. Someone had to use the restroom. Notice here in the book, right? I don't know how closely we've looked at the book in the past, but please note all the key vocabulary is in a green box with definitions. You can read extra about it, but a confidence level, what does it do? It gives the overall success rate of the method used to calculate the confidence interval.
I think this chapter isn't on Schoology yet.
Good to know. I'll update that. I'll update this one and the next one. Because I already have those. But the interval computed from the sample data will capture the true parameter in C% of all possible samples when the conditions for the inference are met. This is clutch right here. If the conditions are not met, does it capture the parameter that often? I mean, we just looked at it with the sample proportion one, right? When we violated the law of large numbers, did it capture the parameter 95% of the time?
No.
No. So we're going to look at what those conditions are, but one of those with proportions is very much what?
Normal.
It has to be approximately normal, but what's going to allow us to assume approximate normality?
Sample size being above 30.
Super close.
Significantly large.
Does this go with proportions?
Yes.
No, that's the central one.
That's central limit theorem with means. We've got to keep them straight. Central limit theorem is when the sample size is significantly large. What did I just... Oh, I kept saying law of large numbers. That's not what I meant to say. Large counts is what I meant to say. My bad, guys. We were violating the large counts condition.
So essentially, large counts and large numbers.
So, 1 second.
Wait, is large counts in the 10%?
So So that's the 10% condition, and that's about independence. We're gonna talk about that soon, so we do need to keep this in mind. Sorry, so remember, law of large numbers is the idea that in the long run, our proportion of success approaches the true proportion, right? So in the long run, if we have not violated the conditions, 95% of those intervals will capture the true parameter, right? Or the parameter. Large counts is that the expected number of successes and the expected number of failures with proportions is greater than or equal to 10. That checks approximate normality. And guys, I get it, there's a lot of vocabulary that we have to keep straight. And I even messed up on that one, it happens, right? Law of large numbers is all about probability, that 95% confidence level. Large counts is about normality with proportions. Okay. And so here is the biggest, I'll let you write that for a second first. I would make a note to myself to highlight, pay attention to page 540 in the textbook. I think that's part of what we're supposed to be reading right now. Page 540 is key. Make a note where it says, how do you interpret a confidence interval? Page 540. We're asked about how do you interpret, what page are you going to write there? 540, there we go. So here's literally what we got to say. Like there is, don't be wishy-washy about it, don't deviate from it. If you're asked to interpret a confidence interval, we are 95% confident that the interval from blank to blank captures the parameter and context, right? So when we got this value earlier, and we used 2 standard deviations, right? How would we interpret that? We are,
in that case, 95% confident that the interval from 0.5862 to 0.7426 captures the population proportion of water on the globes.
So would you say, like you are 95% certain or approximately 95% certain?
well, we're going to learn what exactly 95% is, but we are 95% confident that that interval captures the true proportion of ocean on the globe. That's it. We use that format every single time. Notice the whole focus is that we are capturing the parameter. Yeah, I do like the note that they do have there, based on the sample, we are 95% confident. Because our samples can be wrong, but based on this sample, we are 95% confident. Couple of things to look at here. I do want you to look at this AP exam tip. Again, these are the things that we have got to pay attention to. It says when interpreting a confidence interval, make sure that you're describing the parameter and not the statistic. Because if you were to say we are 95% confident the interval from 0.613 to 0.687 captures the proportion of U.S. adults who admitted they would experience financial difficulty. Well, they admitted it. We know what percentage, right, who admitted that they would experience financial difficulty. What is this interval capturing?
Who actually do.
Who actually would experience financial. Right. And so it's not about the sample, it's about the true proportion who would experience financial security. Make sure that you don't use language that talks about the sample when you're interpreting. That context needs to be about the true proportion of blank. Okay? So make sure, or in this case, who would admit to, right? Not who admitted, but who would admit to experiencing some financial difficulty. All right. A detail that we need to look at here in the book. What do they call this thing that you're adding or subtracting to the point estimate?
It's a margin of error.
It's a margin of error. You remember how this thing right here was called a standard error? That's the S sub P hat, that's standard error. And so when you multiply that by a test statistic, that's a z-score essentially. When you take a z-score and you multiply it by a standard error, you are creating a margin of error that tells you the width of your interval. Right? That margin of error is telling you the width of your interval.
Why would we not say range of the interval?
Say again.
Why would we not say range?
Well, statistically, remember range is just the length from the minimum to the maximum. You got to remember in statistics, range is only distance. It's max minus min.
You just sounded like.
But here, we're talking about the width, and I should say the width from the point estimate, right? The width from the center.
The width right there is the margin of error.
The distance from the point estimate to either side is the margin of error.
Okay.
Notice that's why we both add and subtract, right? That margin of error is built on the standard error times the number of standard deviations, right? The number of standard deviations there. And notice if you need more in the book, what page can you see for more about margin of error? 941. Yeah. Every time there's a key vocabulary word, the book literally says definition, and it gives you that word there. I will upload these during advisory, or at least today, before I leave school.
They're all in group chat as well. I've really been sending you the entire time.
Alright, let's see. Sorry, we talked about how to interpret a confidence interval. So what is the structure of a confidence interval? Right, so what do we put at the beginning when we write out a confidence interval? That was the point estimate. Well, remember the estimator is p hat or something like that. The point estimate is the actual value.
Yeah.
And then what do we do to the point estimate? We
You take the
think about the next piece of this.
standard error,
Do something with that standard
Oh.
error.
plus or minus margin of error.
Right, remember the standard error is a part of that margin of error. Okay? So point estimate plus or minus the margin of error.
Is there gonna be a symbol for that that we learn?
Margin of error, ME. Is the most common thing, but there's not a symbol for it.
Is it in parentheses here or just?
No, just capital M, capital E. Alright, do this for me because we are running out of time. Tonight, I just need you to attempt A, B, and C here. There are 3 homework problems to help you practice with them. Notice they are all odds. Don't forget the solutions for every question that I give you in the book is already on Schoology. I'll make sure these things are uploaded. But attempt A, B, and C tonight. And then we'll get to, we've actually already done some of this next lesson, which is good. Yes.
Just make a good.
Okay. So, hey guys, do this for me. Do A, B, and C. Fill out these notes right here. This is just the next 2 questions. We actually already did this with the applet, right? So, this ties into that. Finish through here. What I do need to ask is who everyone has for advisory.
Mr. Mack.
That's where I get my lunch from, because I don't go to lunch.
Ain't that issue? Because it's the lunchroom, it's the Zoom.
I hate lunchroom so much.
Okay, as long as you coordinate with Haley and come, and Haley comes, then we'll, in the morning, okay. So, let's see, Deacon, who do you have?
No one.
No one. Tyler?
So right, she'll do it anyway, she don't have to email her.
It's fine, I'll just email it to be safe. Let's see, who else do I need? Ashton?
Stegall.
And then Austin? Blair? Okay.
Isaac.
Isaac Lexi, okay. Lexi,
Davis.
Donnie Davis?
No.
Haley, you can't stay, Peyton?
I can't stay today, but I can come early tomorrow.
Okay, let's do that. Let's see, Logan,
McDonald.
McDonald, big or little? Big?
Maybe like